Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com. This video is another in my series of RHCSA practice sessions as I prepare for the Red Hat Certified System Administrator exam. Just want to remind you these are not necessarily intended to be authoritative information as much as it's me going over the topics to see if I feel confident about them and potentially identify areas where I need to do some additional study before my cert exam. But that being said, I do try to give some accurate information about it, and maybe I might present some stuff in a way that you yourself haven't thought of, and it might help with your own studies. If you enjoy the content, make sure you click like on the video and also subscribe to the channel and ring the bell when you do. So this video is going to be about the create, mount, unmount, and use vfat, ext4, and xfs file systems within the create and configure file systems section of the exam objectives. So there's a lot that can probably go into this, and of course obviously I haven't taken the RHCSA exam yet, but I'm kind of thinking from the perspective of, like, if I were interviewing a person, what would I want them to be able to tell me about these things if they were interviewing for a systems administrator position. And so those are the things I'm going to try to demonstrate and talk through for this practice session. So creating and mounting file systems, what I'm going to do, let me sudo into root, and let's go to my dev directory. And I have a couple of extra block devices I've attached to this VM, VDB, VDC, and VDD. What I'm going to do, even though I could probably just attach a file system to the block device itself, I'm going to go ahead and make a single partition on each of them that's a partition for the entire block device. And I'll use fdisk for this. And let's do VDB. This will be our vfat one. Actually, I don't have to do dev at all, so I'm in the directory. VDB and new for partition. Primary partition, partition 1, first sector, last sector. We'll do the whole thing. And we're going to change the label type, and this is going to be a FAT file system, or X. Let's see if there's a particular one for vfat. I don't think there is. Let's see, exfat, yeah. We'll do number 7, hex code 7. I think that's what we'll need for that. All right, and we'll write this and part probe. Actually, let's do the rest of the disks as well. Go ahead and do our other block devices. So VDC, these will be Linux file systems. New primary. Keep the defaults, and we'll do dev vdd, again keeping the defaults. And we have our block devices. All right, so we're going to start with the vfat file system. Now, the command that we're going to be using to make a file system is going to be the mkfs, or make file system command. And you can do mkfs-t and feed it the type, or a lot of the common types, you can do mkfs dot the file system type. And I wanted to look up about xfs because I was just curious if I do man makefs x or vfat, not xfs. And the man page comes up for makefs fat. All right, so not necessarily the end of the world, but it's kind of a curious thing. So if I were to do which makefs vfat, I see its full name, and I was just curious, sbin makefs vfat, that is actually a symlink to makefs fat. And just as a curiosity, what provides vfat. And it looks like the DOS FS tools package is what provides us the makefs vfat. And I'm not 100% sure if this is already available on a minimal install. Obviously it is here on a GUI install, but I would imagine maybe on the test, if you try to do mkfs vfat and you get an error, then the what provides should be able to get you the package that you need to be able to make that work. So all I'm going to do, we're going to use the vdb1 for vfat. And to create a file system, literally, you're going to mkfs vfat and then the device name, which in this case would be dev vdb1. And now we have a file system. It's that simple. I like using block ID to get UUID for items, and we see, let's see, vdb1, yep, there is the vfat file system type. There's our UUID. I'm going to go ahead and copy that, because part of the objective is we want to mount and unmount these file systems, and if we want to mount permanently, then we need to alter the RHCSA tab file, which we'll do near the end of this video when I do a permanent mounting of the file systems. And to do that, we're going to need that UUID. But if I wanted to mount vfat, mounting basically means we are going to take this file system and make it available for use. And the way the hierarchical file system works in Linux, it really doesn't care what is providing the storage. What I mean by that, let me do df-h, so display file systems, and we see that the root directory is mounted on dev mapper-cl root. Yet the boot directory, which is within root, is mounted on dev vda1. So from our perspective with the file system, we have root and then root boot. Then eventually you see there's some temporary file systems, root, run, user, 42, on and on and on. But each of those locations in the file system, different storage can be used for that. All right, so within the mnt directory, we're going to make a folder. We're going to call it vfat, and we're going to mount this file system that we've made onto vfat. And a couple ways of doing this. Mount is pretty smart in the fact that it can figure out the file system for most things on its own, but let me go into the man page for mount. It's probably not a bad idea to use the -t option and tell it the file system that you're using. You can also give additional options, such as force it to be read-only or read-write, all that. There are also some defaults that mount uses, which you can dig into the man page and probably look up user share doc to get some information about that as well. But if we want to mount -t, this is going to be vfat, and we are mounting the dev vdb1 device. We're going to mount that to mnt vfat. And if I were to do df-h, we see that this device, that's 5 gigs in size, is mounted to mount vfat. Let's make a little file here, test vfat file. I'm going to send that to mount vfat test file vfat, and we can cat that, and there we go. Now, part of the objective is unmounting that. So to unmount what we have, we would use the umount command, and I believe we can do this either on the mount point or the device that has the file system on it. And I'll show you the difference. So we're just going to umount mnt vfat. All right, and if I do df-h, we see, I'm going to raise my window up here just a bit, and we see that that's no longer there. So let's mount it again. Oh, on that note, let's ls mount vfat. We see there's no file there because we took away, even though, or rather we see there's no test file vfat. The mount vfat directory still exists, but we've taken away or we've unmounted the storage for it. So whatever data that was stored on there is now gone until we remount the file system. The file system still exists, we just haven't mounted it to a directory yet. So if we were to do again mount -t keep thinking xfs vfat to mount vfat. Odd. What am I doing wrong there? Oh, maybe if I give it a device, dev vdb1 mount vfat. Of course, this is just a screen share, but if I had the camera on me, you would have seen my own little eye roll at myself, where I can't believe I forgot the device. df-h, we see it's mounted, and then if we ls mount vfat, we see our files back. Now, for umount, we can also do the device itself, if I'm correct. So dev vdb1, and our file system is gone. I'm going to mount it or our file system's not gone, rather we have unmounted it from mnt vfat. So I'm going to mount it one more time, and I'm going to show you one thing that could go wrong if you have an objective or a task where you're having to unmount something. So if I were to mount dev -f, what am I thinking? T vfat dev vdb1 mount vfat, and I'm going to change directory into here. List of contents, there's my file. If I were to try to unmount this, umount, it's going to complain that the target's busy because I'm currently in that directory. So you would need to be out of the directory to be able to unmount the file system. Now, this idea of mount unmount works the exact same with the other file systems. I'm going to go ahead and create an ext4 as well as an XFS file system on our other devices. So let's look at ls block. So we have VDC and VDD. I'm also going to go ahead and make directories for them in the MNT folder. Now, you don't have to use the MNT folder for this. I mean, you could mount, as actually you can see here, you can mount a file system anywhere. But the MNT directory is kind of a typical place where you would want to do this. And I would imagine, especially since this is really kind of a temporary thing that I'm doing just for this this practice session, it especially makes sense to use that directory. So we'll make dir mnt ext4 and mnt xfs. All right, so now we'll use fdisk again, and we'll wait, we don't need to do that. We've already made our partition, so we'll make fs. I'll use the -t option this time just to show that. ext4, and the device we're making the file system on is VDC1. All right, so we now have an ext4 file system. We can mount ext4 dev VDC1, and we're going to mount that to ext4. Make another file system. This time I'll use the dot syntax. mkfs.xfs dev vdd1. It makes the xfs file system, and then we'll also just let mount figure it out. So dev vdd1 mount xfs, and it should be able to do that. df-h, and we see that we have our file system. Look at the man page for df. I think there's an option that shows the type. Am I right? -t, that's it. So df-ht, and that shows you the type of file system that we have. So we have our vfat, our ext4, and our xfs all mounted. And then of course to unmount that, we can use umount. The other thing I wanted to cover is making this persistent, because that's part of the RHCSA exam. Anything you do, or at least everything I've read that says this is how it is, anything that you're going to be doing, you have to make persistent. So that means we have to work with the ext4 tab file. So if I were to vi into ext4 tab, we see a couple of things. Notice we have the root and boot volumes that are here, and anything that's in this file is going to be mounted at the time of boot. Hence why it makes this persistent, because if it's in this file, the system's going to try to mount it. So one thing that I tend to do is use UUID when I make my mounts. Now you see here the boot volume or the file system that is mounted to boot is done with UUID. The others are by device. You can also use labels as well, but I personally, as I said, I tend to use UUID just to where there's very little chance of that conflicting with something else and the wrong thing trying to be mounted. Now, since I'm in a GUI environment, I could easily have another window, do block ID, and get the UUIDs there and copy. But if I was in an environment where all I had was the console, I had no other way of doing this. I'm going to show you a little trick here, and I've mentioned this in another video as well. I'm going to go into command mode, and R, which is going to write whatever command that I've done into my VI document here, exclamation point, block ID. And so there is all of the output for block ID right here in the VI file. So we're going to delete a few of these using DD for that. I'm going to keep a couple of these. So here are our file systems, the vfat, the ext4, and xfs. I'm going to go into insert mode, and let's do a little cleanup here. Oops, hit page down by mistake. I'm on a Lemur Pro doing this, and I really love my Lemur Pro. However, I hate the fact that the arrow keys are like the half width keys, or maybe half height, depending on how you look at it. And what would be in like the space of them are page up, page down. And so I tend to hit page up, page down when I don't intend to, which when you're working in VI can be kind of annoying. So I get my UUIDs. I've tested this both with having the quotes and without having the quotes, which as you can see for the boot directory, and it seems to not make any difference. All right, so our UUID, this is our vfat thing. We're going to mount it to mnt vfat. The file system type is vfat. And here, if we wanted to apply different options, different file systems are going to have different capabilities. For this, and I have a feeling this is probably going to be true for the exam as well, using defaults will likely be fine. So we'll do defaults. And then this 00 here, what this is saying is the first 0 is making like dumps available for backups, which we're not going to be doing for this. And the second is if it should be checked by FSCK, and I'm not really interested in that for this particular file system, so we're going to leave that at 0. And we're also going to delete this other information here. And we'll rinse and repeat for the other two. We don't need to keep this information here. We're mounting our ext4 file system to mnt ext4. File system type ext4, and I'm just putting a tab separation between these. And same thing for our XFS. So mnt XFS file system defaults 00. And we'll close this. So I'm going to go back to my home directory. I'm going to unmount all of these. And I'm doing this via the device. So if I do df-h, they're all gone. So a way to test whether or not your persistence is going to work, and this isn't 100% true all the time, but for just doing basic, you have a file system, you've mounted it to a directory, we can do mount-a, because what that's going to do is read the ext4 tab file and mount everything that it can from there. So if I do df-h, we see that our file systems are mounted. Let me ls mnt vfat, and we see that our little test file is there. So rebooting will do the same thing, but in the test environment where rebooting is going to take a few seconds, you can probably save a few seconds and do the testing by doing mount-a. So that covers the creating, mounting, and unmounting, and using. Well, let's see, use. We made a file. How would I define use? Well, you can use tune2fs and xfs underscore admin to make labels for file systems. I covered that in the configure local storage video. You can also do some, I know you have xfs repair, and you also have the fsck for ext4 file systems for file system repair. And you are able to actually grow XFS and ext4 file systems. ext4 you can actually shrink it as well. I'm not quite sure why you'd want to do that, but it's capable. I'm not going to demonstrate that in this video because I think there's another objective that deals with altering the file systems like that. I do want to look at one thing before I go. So vfat, no man entry for vfat. Let's do mkfs vfat. What I'm looking for is if there's a utility. Sometimes it will show that fat label. There we go. All right, and we have fsck for fat as well. So let's look at man for fat label. Faithful B, yeah. There we go. And does this allow you to create? Yep, you can create a file label. So if you were doing that for your vfat, you can use fat label, looks like, for that. But I would imagine many Linux environments we're not going to be using the vfat file system that much. But if you do have something that needs to communicate with both like Windows and Linux, vfat might be a way to go for that. This basically covers this topic. If you enjoyed the video, make sure you click like. Also subscribe to the channel. Don't hesitate to share with others that may find it useful, and feel free to leave a comment. Thanks for taking the time to watch, and I'll see you the next time.